Today we'll be doing section 7.2, similar polygons. Earlier we have talked about congruent polygons, and that's when they are the exact same size and the exact same shape. Well, today similar polygons have the same shape but not necessarily the same size. Okay, so one's going to be a little bit bigger or smaller but the exact same shape. The notation for similar is going to be this little swirl with no equal sign underneath. So it indicates that it has the same shape, but not necessarily the same size with the equal sign. Similar polygons will have two things that they will definitely have. Corresponding angles will be congruent, that's for sure. And then the second thing is corresponding sides are proportional. So all the side lengths are going to be exactly twice as big, or all the side lengths will maybe be 1/3 the size, but they will all be proportional in the size. And then I mentioned in the last section, a scale factor is just the ratio of the lengths of the corresponding sides. So you're going to put the corresponding sides in a fraction and then reduce that, and that will be your scale factor. Theorem 7.1 says if two polygons are similar, then their perimeters have the same scale factor as their corresponding sides. So that just means if my side length is twice as big, the entire perimeter would also be twice as big. So they are the same scale factors. Okay, let's go ahead and work with number 1. As you can see, it says each pair of polygons is similar, and when they do write up these letters, the order is in the corresponding order. So I definitely know that angle Q is congruent to angle S. I can say QR for the left side would correspond to SV for the right side because of this order right here. QR and SV are both the first two. So the same order, just like we did with triangles. So I'm going to look at my diagram here, and I'm going to just go ahead and set up a ratio with just these two sides here. I'm going to say 4/12 is how I'm going to set it up. And then I'm going to go ahead and look at what 4 corresponds to. So as you can see, 4 belongs to RP, and over on the right, the second and the third would be VZ. So VZ here would be the 3x minus the 1. So since 4 was on the top, that would also have to be on the top. And then the 12 corresponds to 8x minus 1. Now I'm going to go ahead and cross multiply, but if you want to reduce before you go, you can also do that. So I'm going to reduce just so I can work with smaller numbers. When I cross multiply, I'm going to say 1 times this lower parentheses will be 8x minus 1, it won't change, and then 3 times this top parentheses is going to be written like this at first, and then I'm going to distribute. So I'm going to have 8x minus 1 equals 9x minus 3. I'm going to go ahead and subtract 8x to the right. And I get -1 equals x minus 3. Let me go ahead and write it over here so we have more room. Add the 3 over so we can get x by itself. And I get 2 equals x. So that was what I needed to solve. I'm going to go ahead and rewrite it so x is written first. Over here on number 2, I have a whole bunch of angles in here. So I'm going to first start off, I'm going to look for my x, and I see it right here. And x plus 34 is for this angle D. The CD is the last letter written, so it's going to be congruent to this corresponding P. So sometimes you have to look at the diagrams. The diagrams might be turned or rotated, so make sure you definitely check to see which one is the corresponding angle. So I'm going to go ahead and say x plus 34 then equals 97. Subtract 34, and I get x equals 63. So there's a lot of more information here, more to check to see if you are looking for the corresponding angle. Okay, I have to solve for y, so grab this one here, which happens to be r, and r is this third one, and so that would be congruent to c over here, which is 43. So I'm going to set it up with 3y minus 13 equals 83. Let's go ahead and add 13 to the right. And I get 3y equals 96. Divide by 3. And I get y equals 32. So always look for the correct corresponding angles that are congruent. And if you see the letter is written in the same order, that's how you tell which one corresponds. Okay, so in example 3 and 4, we're going to talk about finding the perimeter. And as you wrote down in theorem 7.1, the side ratio or the scale factor is the same as the perimeter ratio. So I'm going to write this up as side ratio. It's the same thing as the scale factor. And then over here I'm going to put the perimeter ratio, just so I organize my work. We have two triangles. They have it in the directions that WZX is similar to SRT. They also have in the direction 6, but as you can see, it's already marked in our diagram. The WX is marked in our diagram as well. So I'm going to be consistent, and I'm going to write all my information for triangle WZX I will have on the top of my fraction, and all the information for the triangle SRT will be on the bottom, just so I can organize my thoughts. So that being said, I had to find a side ratio with these two numbers, and as I told you earlier, triangle WZX will have the information on the top, and then triangle SRT will have the information on the bottom. And then the theorem 7.1 said the side ratio is equal to the perimeter ratio, and since I know that the perimeter of SRT here is already 15, even though I don't have all the information for the other additional sides, they did give me that the perimeter is 15, and since SRT is on the bottom, I'm going to put it on the bottom of my fraction. And then the perimeter that we are looking for, WZX, is unknown, so I'm going to put an X, and again that goes on top because that's where all my information for triangle WZX goes. So now I'm in a situation where I can just cross multiply to solve it. I get 6x when I cross multiply that way, and I get 75 when I cross multiply. Get rid of the fractions. Now I'm going to divide by 6, and I get x equals 12.5. So if you need your calculator, go ahead and grab it. They're asking what the perimeter of WZX is, and I called it x. I should also be more specific and put down perimeter of triangle WZX is 12.5, and then that's my more exact answer right there. Okay, and number 4 for my final example, we're going to try to find the perimeter here of triangle CBH. So the first thing I'm going to look for is finding that triangle CBH here. There's lots of shapes in this diagram here, so highlight it. And then the only other triangle I see some measurements on is right here with H, F, and E. So I'm going to highlight this one as well. So I'm going to use those two. And they also had told me FEH is similar to CBH right there in the directions. I'm going to organize all my information here. Let's start off by saying CBH will always go on the top, just to organize. All the information for triangle FEH will go here on the bottom. I'm going to also write my little note here. We'll put the side ratio on the left of our proportion, and we'll put the perimeter ratio on the right. And again, the perimeter ratio is the same as the side ratio. That's why we are allowed to cross multiply and find the perimeter that we're missing. All right, so I'm looking at the green one here. CBH, and the only measurements I have are 7 in there. So 7 is the only choice I have for that green triangle. And now it is CH. So CH is the first and the last letters of that order. So I need to go find a corresponding one for the pink triangle. First and last would be FH, and FH is the value 10. So sometimes it's not as easy to see from the diagram. Double check with the corresponding letters. Okay, back to the green triangle. I need to find the perimeter, so I'm going to call that X. But with the pink triangle, I can add all these numbers up for my perimeter. So 16 for those two plus the 11 gives me a total of 27 for the perimeter. And that's enough information now for me to cross multiply so that I can solve for X. And X represents the perimeter of that top triangle. So 10 times X will be 10X. And 7 times 27 is 189. When dividing by 10, not too bad, it'll just move that decimal. So X equals 18.9. And like I did with number 3, let's write out our answer. We'll say the perimeter of triangle CBH, because that's what we were asked to find, is 18.9 units. All right, so that was the last of my problems. So like always, if you have questions, make sure you ask me when you see me again.